Imagine walking through a dense, humid forest. The trees tower above you, ferns as tall as houses crowd the undergrowth. Suddenly, the air shifts. A shadow glides overhead. Not a bird. Not a bat. But a giant insect, wings buzzing like a drone, eyes glinting like glass. That's Meganeura, Earth's ancient dragonfly-like titan. With wingspans up to 27 inches, 70 centimeters, this aerial predator ruled the skies during the Carboniferous period. Let's dive into the story of this magnificent insect giant, a creature that looks like it flew straight out of a sci-fi film, but is 100% real, preserved in stone and mystery. Let's get straight to the size. Meganeura looked like a dragonfly, but on prehistoric steroids. With wingspans reaching over 2 feet, it was the largest known flying insect to ever live. That's bigger than many birds of prey today. If you were around 300 million years ago, you'd be sharing airspace with a buzzing, 4-winged predator large enough to mistake your pet frog for a snack. Fossils of Meganeura were first discovered in France in 1880, and they astonished scientists. The perfectly preserved wings showed the classic netted pattern of modern dragonflies but at an exaggerated scale. These weren't just bugs, they were aerial hunters, built for speed and precision. Despite its fearsome appearance, Meganeura likely weighed only a few ounces. Its light exoskeleton and large surface area made it perfectly suited for flight in the oxygen-rich atmosphere of the Carboniferous. This was an insect engineered by nature to dominate the sky. One of the biggest scientific questions about Meganeura is, how did it get so huge? The answer may lie in the air. During the Carboniferous period, Earth's atmosphere contained up to 35% oxygen, much higher than today's 21%. This supercharged air allowed insects, which breathe through tiny holes in their exoskeleton called spiracles, to absorb far more oxygen without needing lungs. The richer the air, the bigger the insect. Meganeura wasn't alone in this evolutionary boom. Giant millipedes, spiders, and centipedes also thrived in the forests. It was a golden age of creepy crawlies. When oxygen levels dropped later in Earth's history, these giant insects couldn't sustain their size. They either shrank, like modern dragonflies, or vanished altogether. So, in a way, Meganeura is a relic of a high-octane atmosphere that no longer exists. It grew large because the air let it. When the air changed, it couldn't keep up. Think dragonflies are good hunters? Meganeura would make them look like amateurs. Fossil studies and comparisons with modern dragonflies suggest Meganeura hunted the way its smaller cousins do today, with lightning speed, incredible eyesight, and a deadly mid-air grab. It likely preyed on other insects, small amphibians, and even early vertebrates. Imagine being a tiny reptile and suddenly being snatched from the air by a winged horror with huge mandibles. Its compound eyes, each made of thousands of lenses, gave it nearly 360-degree vision. This meant it could spot prey from far off and adjust its flight mid-air. No buzzing mosquito would escape this hunter. A short story: picture a small, tree-dwelling amphibian clinging to a fern. It hops into the air, unaware. A shadow passes overhead. Before it lands, it's caught mid-leap by a blur of wings and jaws. That's how quick Meganeura likely struck. Most of what we know about Meganeura comes from fossils, and they're stunning. Found mainly in coal deposits, these fossils often preserve wings so clearly you can count the veins. The best specimens come from France, Germany, and England, where ancient swamps turned into carbon-rich rock layers. The anaerobic conditions of these swampy environments helped preserve even delicate structures. In museums, these fossils look like artwork. The wings, spread out like lace, appear almost too perfect to be real. But they are, etched into stone by time and pressure. Modern imaging techniques, like 3D scanning and synchrotron radiation, have let scientists explore these fossils without damaging them. We can now see not just the shape, but the internal structures that supported flight. These fossils also help answer bigger questions: how flight evolved, how ecosystems adapted, and how climate change shaped life over millions of years. Let's go full sci-fi. Could a Meganeura ever buzz through our skies again? Well, maybe not exactly, but the idea isn't as wild as you think. First, the oxygen issue. Without a high oxygen environment, it's hard to sustain large insects. But what if we recreated such an atmosphere in a controlled dome? Scientists have already grown larger than normal insects in high oxygen labs. Second, the genetic problem. We don't have Meganeura DNA, but its modern relatives, like dragonflies and damselflies, still carry ancient genes. Could synthetic biology someday create a hybrid? Perhaps. But beyond the lab, nature sometimes echoes its past. Some of the largest dragonflies today can reach 6 to 7 inches in wingspan. While nowhere near Meganeura, they're still impressive, and proof that big bugs haven't vanished entirely. Whether or not it returns, Meganeura reminds us that our world was once wilder, weirder, and buzzing with giants. So here's the question: if you could safely meet a Meganeura, would you want to? Would you let it land on your arm? Or would you run for cover? Let us know in the comments. What surprised you most about this prehistoric flying giant? Be sure to like, share, and subscribe for more journeys into Earth's ancient mysteries. Until next time, stay curious, stay adventurous, and maybe watch your head. You never know what's buzzing above.